Let us solve question number 23, guys. So what we have here, at 300 K, the vapor pressure of a solution containing 1 mole of N-hexane and 3 moles of N-heptane is 550 mm of Hg. So let us highlight the data that is given: 1 mole, 3 mole, 550. Okay. At the same temperature, if 1 more mole of N-heptane is added to this solution, the vapor pressure of the solution increases by 10 mm. So we are adding how much? 1 more mole, and vapor pressure increases by 10 mm. What is the vapor pressure in mm of Hg of N-heptane? So we have to find out the vapor pressure of N-heptane. Okay, so how we'll go about it? Let's see. First thing, number of mole of N-hexane is 1 mole and that of N-heptane is 3 moles. Okay, so mole fraction of N-hexane would be 1 by 4. 1 by 4 into the vapor pressure. Let's say P1 is the vapor pressure of N-hexane. Okay, plus what? Plus the mole fraction of N-heptane. Mole fraction of N-heptane would be 3 by 4 and vapor pressure of N-hexane will be P2. So this is how we'll give the total pressure. This is how we'll give the total pressure, and this will be equal to how much? This will be equal to 550 that is given. Okay, so our first equation becomes P1 plus 3P2. This is our equation 1. Let us go in the second part of the question. At the same temperature, 1 mole of N-heptane is added. So you are adding 1 more mole of N-heptane, guys. Okay, so if we add 1 more mole of N-heptane, so mole fraction of hexane would be how much? Mole fraction of hexane would become 1 by 5 and vapor pressure of N-hexane is P1. Yes, plus what would be for N-heptane? N-heptane mole fraction becomes 4 by 5 and the vapor pressure is how much? Vapor pressure is P2. And what is the total vapor pressure, guys, at that point of time? Let's see. It is increasing by 10 mm. So the vapor pressure becomes 560 mm. It becomes how much? 560 mm. So the total pressure is how much? 560. Let us solve this further. So this will become this is our equation 2, guys, right? So if we solve equation 1 and 2, what we'll get? We will get P2 is equal to how much? P2 is equal to 600 mm of Hg. P2 is how much? 600 mm of Hg. So that is our answer, guys, because we had to calculate for heptane and P2 is the vapor pressure of heptane that I have already told you all. So answer is 600 mm of Hg. 600. Okay, let us move on to question number 24, guys. So what we have here, the mass of ammonia in grams produced when 2.8 kgs of dinitrogen quantitatively reacts with 1 kg of dihydrogen. So it's a question based on stoichiometry, guys. Okay, so let us see how to solve it. We'll first have to identify the limiting reagent. Okay, and from the limiting reagent we'll be able to calculate the mass of ammonia. Okay, so first, number of moles of N2 and number of moles of H2. So this will be 2.8 into 1000 divided by 28, and this one will be 1000 divided by 2. So this is how much? This is 100 moles and this is 500. Okay, if I write the equation, so what I have, N2 plus 3H2 gives you 2NH3. N2 plus 3H2 is giving you 2NH3s. So what is the limiting reagent over here? N2 given over here is the limiting reagent. So we'll calculate the mass of ammonia from where? From N2. Okay. So let's see. So 1 mole of N2 gives you 2 moles of ammonia. 1 mole of N2 giving you 2 moles of ammonia. So 100 moles of N2 will give us how much? Will give us 200 moles of ammonia. So we have got the moles of ammonia. Now we'll calculate the mass of ammonia. So mass of ammonia would be how much? Mass of ammonia will be moles of ammonia multiplied by the molar mass. So this is how much? This will be 3400 grams. So mass of ammonia is 3400 grams. So that is our answer is. Okay. So I hope you have understood this. A very rare thing, that is a question on stoichiometry, but a scoring question, guys. Okay. Let us look at the last question of this shift, that is question number 25th. A 20 ml solution containing 0.2 grams impure H2O2. So we have 0.2 grams of impure H2O2. H2O2 reacts with 0.316 grams of KMNO4. So it is reacting with 0.316 grams of KMNO4 in an acidic solution. We have to find the purity of H2O2 in percentage. Okay. Molecular weight of H2O2 is 34. Molecular weight of KMNO4 is 158. So we'll solve this question by equivalence, guys. Okay. So equivalence of KMNO4, is equal to equivalence of H2O2. So how we'll find the equivalence of KMNO4? So this will be 0.316 divided by 158. What would be the N factor of KMNO4 in acidic solution? There will be exchange of 5 electrons. So the N factor is 5. So I'll multiply this by what? I'll multiply this by 5. So that will be the equivalence of H2O2. That will be the equivalence of H2O2. This will be the equivalence of hydrogen peroxide. So the equivalence of H2O2 will be how much? It will be 0.01. So that is the equivalence of H2O2. Now what we will do is, we will find out the number of moles. How to calculate the number of moles, guys? Let's see. So equivalence is nothing but N factor into number of moles. So what I have over here is 0.01 is equal to N, that is number of moles, into the N factor of H2O2. What will be the N factor of H2O2? N factor of H2O2 is 2, guys, right? So number of moles of H2O2 will be, 0.01 divided by 2. So that will be how much? That will be 0.05 moles of H2O2. Okay. So now we'll convert it to what? Now we'll convert it to mass. We'll convert it to what? Mass. How to convert it to mass? We will multiply this by the molar mass of H2O2. So what is the molar mass of H2O2? Is 34. So this is 0.005 multiplied by 34. We'll multiply this by 34. So mass of H2O2 would be how much? This is 0.17 grams. So we have the mass of H2O2, that is 0.17 grams. And let us have the mass of the sample, guys. What is the mass of the sample? Mass of the sample is 0.2 grams. We have to calculate it what? In percentage. So how will calculate the percentage? Let's see. So 0.17 divided by 0.2 multiplied by 100. So this would be 85%, guys. Okay, that is our answer, guys. Okay, so that's our final question, guys, and the answer is 85. That completes your paper of 4th September 2020 morning shift. I'll say again, it was a moderate paper. Initial questions were very easy, and then as we moved on to the other questions, the paper got a little tough. Okay, but overall it was a moderate paper, guys. Okay, all the best for your results, guys. Thank you.